What if a function could call itself? Not a loop, not a copy. The same function diving deeper and deeper until it hits the bottom. Then it climbs back up carrying the answer. That's recursion. Let's compute factorial of 5. 5 times 4 times 3 times 2 times 1. Instead of a loop, we'll define factorial as n times factorial of n minus 1. The base case, factorial of 0 is 1. Watch the call stack build. Factorial of 5. That's 5 times factorial of 4. We don't know that yet, so we call it. Factorial of 4. Still needs factorial of 3. Keep going. Factorial of 3. Still needs factorial of 2. Keep going. Factorial of 2. Still needs factorial of 1. Keep going. Factorial of 1. Still needs factorial of 0. Keep going. Factorial of 0. That's our base case. We know this one. It's 1. No more calls needed. Now the stack unwinds. Each function returns its result to the caller above. Base case returns 1. 1 times 1 equals 1. Return 1. 2 times 1 equals 2. Return 2. 3 times 2 equals 6. Return 6. 4 times 6 equals 24. Return 24. And finally, 5 times 24. Factorial of 5 is 120. The entire call stack has unwound. We started with one question and got our answer, 120. Here's the Python implementation. For lines, if n is 0, return 1. Otherwise, n times factorial of n minus 1. The function calls itself with a smaller problem each time until it reaches the base case. Now the cost. Each call adds 1 frame to the stack. Factorial of n makes n plus 1 calls. That's O of n time and O of n space for the stack. The danger: if you forget the base case or the input doesn't shrink, the stack overflows. Every recursive function needs a base case and a step toward it. Quick recap. That's recursion. Dive down, hit the base, climb back up with the answer.